So here we have a new f of x equation. F of x equals 5 plus 4x minus x squared. I'd like you to please find the value of this formula. Plug in, kind of like what we were just taking a look at on the homework. Now, as you're working this through, you have two options, which we haven't even necessarily discussed yet. One option is that you do everything as just one big fraction all the way through, kind of like we did on that last homework problem. The other option is that you could also break it up into individual little pieces. So like I could start by just trying to figure out what f of 2 plus h would give me, and work all the way through on that before going to the next part. That would also be an option. All right, so now that I've gotten to this point, I've figured out what the f of 2 plus h is, what f of 2 is. I can now go ahead and plug those in. Since I did this separately, I can plug that into my original fraction up there. And so I'm going to be doing the 9 minus h squared, and I'm going to be subtracting 9 from that. Now this also shows one advantage of breaking it apart and doing it separately like this. You're less likely to make a negative error when you end up doing minus the whole f of 2 this way. Because if we do minus and then do the calculations all in a big row, you really have to be careful to make sure that you keep track of where that minus goes. All right, so from here, it's just a matter of simplifying, right? So the 9's cancel each other out. I have negative h squared over h. Go ahead and cancel the h out. And this whole thing just equals negative h. Yes, that's simple. Now this formula that we've been using, this one that you just plugged into, the one that you're actually working with on last night's assignment, it's actually a known formula. Actually, it's one that you've seen before. This is just the difference quotient formula. Now, granted, it would be like first semester of pre-calculus that you last would have seen it, and it was often just glanced over, but this is difference quotient formula. And this is something that we're going to be using a decent amount going forward, so please add this into your notes. All right, now a couple little details. This formula should look familiar. Basically, this is the formula that we were using on that assignment last night, even though you didn't necessarily know it explicitly. And you might not necessarily recognize much because the bottom is just h here. The bottom wasn't just h on your assignment, was it? But in these terms, my first x value is a plus h, right? And then I'm subtracting the second x value, which is just a. What does a plus h minus a equal? H. And since that will always simplify down to just be h, that's why the bottom here is just h. But this is still just the slope function. This is just a formal way to write the slope function. It's still just the same old y2 minus y1 over x2 minus x1. It's just been written in function notation and with that h in there, because by writing it with the h, you notice it makes things a little bit cleaner. The bottom is just h. And we actually only need to know one x value. We don't need to know both x values, as long as we know how far apart they are. And so this formula just gives us a slightly different way of being able to approach that slope that might feel a little bit better. All right, and you notice down here a detail. Why do we know it? Just like on last night's assignment, we were finding the slopes of secant lines, and that led us to difference quotient. Well, here we can see that the difference quotient will be used specifically to find the slope of a secant line. This is going to be your homework assignment for tonight. It's going to be page 21, number 27. But you don't have a book, do you? Well, there's an online textbook option. I'll be putting up the code for that in a minute. It's also in your syllabus. And we'll also look at checking the textbooks out to you today as well if you want one.